Assalamualaikum and very good morning to Prof. Madya Dr. Siti Ujila Masuri and my fellow group members. Today we are going to explain and elaborate regarding the application of thermodynamics that we have chosen, which is jet engines. Next. This group consists of three group members, which is myself, Muhammad Khushaini bin Kamaruzaman, with matric number 213141, together with Faiz bin Muhammad Nasser with matric number 210158, and also Muhammad Azim Hilman bin Resyidi with matric number 211997. Next, please. Okay, here is a big description of jet engines. A jet engine is a reaction engine that discharging a jet that generates thrust by jet propulsion, where it is purposely designed for creating large volumes of high velocity exhaust gases in order to overcome the aerodynamic drag of the aircraft. There are a few components that are involved in jet engine, which are fan, compressor, combustor, engines, turbines, and nozzle. These all components associated with the kinetic energy, potential energy, and internal energy that affects the energy balance. Next. Okay, next I will explain the fundamental principle of the first law of thermodynamics that relates to the jet engine. Next. Thank you. So the first law of thermodynamics, that is also well known as the law of conservation of energy, states that the energy cannot be created or destroyed, but it still can be transformed or altered from one form to another. So in the context of a jet engine, this law shows how the energy of the fuel is converted into useful work that propels the aircraft forward. So in a jet engine, the energy of the fuel is transformed into thermal energy through combustion. The thermal energy then expand the high pressure gases and produce a high velocity exhaust jet. So this exhaust jet produce a thrust that propels the aircraft forward. And according to the first law of thermodynamics, the total energy of the system, which is the fuel, the engine and the surrounding air, must remain constant. This means that the energy added to the system in the form of fuel must be equal to the energy to the energy that is transformed into the thermal energy, mechanical work, and heat losses in the engine. So the change of stored energy usually occur within the control volume, and in this case the control volume is the jet engine itself. And to sum up, the first law of thermodynamics provides a basis for understanding the thermodynamic of jet engine and helps engineers design engines that are thermodynamically efficient. This law ensures that the energy of the fuel is not wasted but is used to produce the maximum possible work, hence increasing the performance and efficiency of the engine. That's all from my part. Next, I will pass to the next group member. Thank you.
Thank you, Khushaini. Next, I will explain the second law of thermodynamics related to the jet engine. So, the second law of thermodynamics implies that the complete conversion of thermal energy into work or into kinetic energy of the air is impossible, and that the most favorable situation, maximum production of work, is realized if all the processes are reversible. So next, besides that, the second law of thermodynamics states that the total entropy or the disorder of a closed system can never decrease over time. So in the context of the jet engine, the law is related to the efficiency of the engine. So jet engine work by compressing air, mixing with fuel, and then it emitting to produce a high speed jet of exhaust gases. So this generates the thrust that propel the aircraft forward. So however, due to the second law of thermodynamics, some of energy from the combustion process is inevitably lost as heat rather than being converted into a useful work. So in order to maximize the efficiency of the engine, engineer designed the engine to minimize the entropy production and waste heat. So for example, modern jet engine are designed to maximize the efficiency of the combustion process, to minimize the amount of energy lost as heat, and to capture as much of the waste heat as possible and use it to generate additional power. So in summary, the second law of thermodynamics set limits on the efficiency of jet engine and other energy converting system and drive engineer to design more efficient system by minimizing entropy production and waste heat. So next I will discuss the example of jet engine. So the schematic show a full turbojet engine in which the jet of combustion products passing through the exhaust nozzle generates all of the thrust. So in the turbojet, a multi-stage compressor boosts the pressure of the entering air, and a portion of the high pressure air enter the combustor where fuel is added and burned. So while the remaining air cools the combustion chamber, the hot product of combustion then mix with the cooling air, and these gases expand through a multi-stage turbine. So in the final process, the gases accelerate through a nozzle and exit to the atmosphere to produce a high velocity propulsive jet. So the compressor and turbine are rotary machine with spinning wheel or blades. So other than that, it needed to drive accessories. So all of the power delivered by the turbine is used to drive the compressor in the poor turbojet engine. So I think that's all from me. I pass up to next presenter, Faiz. Thank you.
Thank you, Hazim, for your very good explanations. So today I'm going to speed up my explanations a little bit. So actually, what are thermodynamics that related with our explanation case today? So we need to know that thermodynamics and Newton's third law are these two attribute with each other because it relates and helps with each concepts. So Newton's third law will heavily affect the thermodynamics law that we're going to use for these jet engine cases. So we need to know the systems and the boundaries of the jet engines. Jet engine itself is an open system because the air can flow in and out, but the combustor and also the compression system is a closed system because it has one outlet and one inlet. So for the next slide, like Hazim said, a multiple stage of compressor increase the pressure in the inlet of these jet engines, and a portion of this high pressure will enter the combustor. Hence, the velocity will increase. So, when the velocity increase, of course, the forward thrust will increase and making the airplane to always stay consistent in the high altitudes. Hence, this is one of the concepts that we can use to analyze of thermodynamic related to the Newton's third law. But there is also another concept that we can analyze, that is Brighton circles in the next slide. These two process we can use to studies, which is isentropic compressions. Isentropic compression is actually an expression of compress and expansions that takes place with no flow of gas in and out. So as the jet engines have narrow shapes, the velocity will decrease and the pressure will increase. Hence, it will make easier to be transferred for the combustor process. And for the isobaric combustion is actually a combustion that takes place with a constant pressure. Hence, like again Hazim says, the heat incoming will be high temperature and the tremendously increase and expands, hence create a very high velocity. So as you can see, the combustor itself is a closed system. Hence, the pressure will remain constant during this process until it will be released to the turbines. The turbine also have very specific shapes of airfoil, making the airplane to stay consistent and fly upwards. Hence, that is also one of the concepts that we can analyze for this jet engine case. That is all from us. Thank you.
Thank you.
Thank you.